Welcome everybody to Climate Science AMA. It's really nice to have you all. So with that, Dana, I'm going to let you take it away and introduce our speaker.
Cool. Thanks, Tamara. So we are lucky to have Dr. Deepti Singh tonight, who's an assistant professor in the School of the Environment at Washington State University. She received her PhD from Stanford University in 2015 and was a postdoctoral fellow at Lamont Doherty Earth Observatory. Lamont Doherty Earth Observatory of Columbia University from 2015 to 2018, prior to joining Washington State. Her research aims to improve the understanding of the many ways in which climate change is affecting our society to inform adaptation efforts and disaster preparedness. Toward this, her work is centered on advancing our understanding of the physical drivers of climate hazards, such as heat waves, droughts, extreme precipitation, and wildfires, and how such hazards are affected by natural climate variability and human-caused climate change. Her group's work also examines the impacts of these climate hazards on agriculture, water resources, and air quality. So thanks for joining us, Dr. Singh. I'm going to stop share, and then you can open up your slides and give us a little presentation.
Thanks, Dana. So thank you for inviting me to talk with you about some of the work that I'm doing, and also to try to answer any questions you might have. And so, as Dana mentioned, I'm at WSU. I've been studying climate change for about 12 years, and I thought I'd start with giving a brief introduction for why I started studying climate change, because in my past life, I was actually studying mechanical engineering, and then I was doing aeronautics, and I was convinced that I was going to become an astronaut, or at least try to be one. But I actually lived near Bombay for several years, and if I don't know if any of you remember this, but in 2005, the city received just a massive amount of precipitation, more precipitation than they've experienced in basically the 150-year record we have for the region, and it brought the whole city to a standstill. And if some of you probably know this, that Mumbai is has a population of about 10 million people. So the city came to a standstill. A lot of lives were lost during that event. Infrastructure was damaged, and the impacts of that particular rain event lasted for several months as areas that experienced flooding and people that experienced flooding experienced waterborne diseases, the spread of waterborne diseases in those communities. And so that event really, for me, was something that really started to make me think about just climate in general. And then I also spent a lot of time with my grandfather, who you can see over here, in his village, which is predominantly an agricultural village. And I spent a lot of time around farmers and farm workers, and since then have also returned to talk with them as well. And it made me just realize, how even if we don't think about climate change, climate variability can impact the lives and livelihoods of many of these people. And so for me, it was a very personal reason, because I kind of first or secondhand experience some of the impacts that many vulnerable communities were experiencing. Because every time I called my grandfather, this is what we would talk about, is how farmers are experiencing the impacts of extreme rainfall or drought, and how they're managing that. And so since 2010, I've been working on extreme weather events, and I've studied a number of different types of extreme events. And our knowledge of climate change has increased dramatically over the last couple of decades. And I kind of wanted to talk about a little bit of work that my group has been doing. Let's see here. Sorry, I am going to just turn this off. Okay. So you're probably familiar with the IPCC report, the Intergovernmental Panel on Climate Change, that released a few reports last year that concluded that recent changes in the climate system are widespread, they're rapid, and they're intensifying. These changes, some of the changes that we're seeing in the climate system are in fact unprecedented in at least the last 1,000 years or longer. In particular, we have a pretty good record of global average temperature, which is seen on the right here in this right panel. And this shows us that since 1850, we have warmed by about 1.1 degree. And that warming is unprecedented in the last 2,000 years. So this is a longer term record of global average temperature from instrumental records in the black line, and many other sources of climate information that allow us to extend this record back. And so we are warmer than we have been in the last 2,000 years, and the rate of warming is unprecedented. And so how do we experience this, right? We are experiencing the impacts of this global warming through its impacts on the weather conditions that we experience from day to day, and in particular with extreme weather events. And so I'm just showing examples of a few extreme events that have affected different parts of the US, from Hurricane Harvey that affected the Gulf Coast in 2017 to the Camp Fire, for those of you in California probably remember, the 2018 fires, the heat wave in the Pacific Northwest, and the winter storm that affected, almost more than half of the US in February 2021. Each of these extreme events have had economic losses or damages of over 1 billion associated with them. In fact, Hurricane Harvey, which was one of the most expensive disasters, had damages exceeding 125 billion. And we also see that, with many of these events, we see a number of lives being lost. And in particular, what was really surprising to me, at least, was that in 2021 in the Pacific Northwest, over 1,400 lives were lost because of exposure to unprecedented heat. And so this indicates that our systems, our infrastructure, and people are not adapted to the climate conditions we're experiencing today. And we're experiencing extreme events. We know that the number of billion-dollar weather disasters have been increasing. NOAA, the National Ocean Atmosphere Administration, keeps a record of these billion-dollar weather disasters. And in 2021, there were about 20 separate billion-dollar weather disasters that in total amounted to over 150 billion in damages and over 700 lives lost collectively from these events. And as you can see, there are different types of events that are affecting different parts of the US. In the West, we're experiencing droughts and heat waves. And in central and eastern US, we're experiencing severe storms, hurricanes. So even though there are different types of disasters, the total number of billion-dollar weather disasters across the US are increasing. In fact, this is a graph that shows us the number of these billion-dollar weather disasters. So don't worry about the different colors, but this is basically, the bars basically indicate the number of these disasters that happen in each year from 1980 to 2020. And these include wildfires, droughts, flooding events, severe storms, winter storms. And so 2020 was the year with the most number of these events, and the total cost associated with these events in each year is indicated on the right column. So in 2020, there were the total number of events across the US amounted to over 500 in damages, 500 billion in damages. And there's clearly an increase in the number of these events. Some of this is because we're seeing more extreme events, and some of this is because these events, are affecting our population has increased, our infrastructure that's being exposed to these events has increased, and so part of it is because of that. But part of this trend is because we are seeing more extreme weather and climate events. And these events, when these extreme events happen, they have, major impacts on not just our physical health. Of course, there are some, direct physical health impacts of many of these extreme events, from heat stress and heat-related illnesses to waterborne diseases in areas that experience flooding, to also impacts on mental health. So, communities that experience disasters are also, show signs of experiencing PTSD. There's, increase in violence during these events. There's, additional stress and anxiety associated with being exposed to these events. And in addition to the physical and mental health, there are also impacts on community health in terms of increased violence, increased social instability that tends to be associated with these different extreme events. So extreme events are affecting many aspects of our lives. They are, in addition to experiencing our health directly, they're also experiencing many aspects of our lives, from the air we breathe to the food we eat and the water we depend on. All of the natural resources are being impacted by climate change, and in particular by extreme weather events. And for many of these types of events, we're actually now able to link individual events to human-caused climate change. So when I started my PhD in 2010, if you asked a scientist, like, okay, is this particular event caused by climate change? Most of the times people would respond by saying, well, we can say that these types of events are changing, but we can't really link a specific event to climate change. But in the last in the last decade, we have seen the science of attributing individual extreme events to climate change really grow. In fact, some of my early work during my PhD was contributed to this field. Starting with the drought in California, to Hurricane Harvey, to the heat wave in the Pacific Northwest, and to the flooding that is occurring in India and Pakistan right now. Many of these events are being linked to climate change. So we don't want to, so that we don't have we don't want to say that this event is caused by climate change, but we know that climate change is affecting the frequency and the severity of these events. And so the science of linking individual events to climate change has advanced quite a bit. And this has happened because, well, we have more data, we have better models, but we also have a much stronger understanding of how climate change can impact different types of extremes. So heat is one of the most well understood impacts of climate change. With a small change in the amount of warming, we see an increase in the number of extreme heat events. So again, I'll just replay this for you. So if we look at the distribution of temperature, this graphic basically shows us the distribution of temperature in the present climate, and with warming, this shifts to the right, which means that we're seeing many more extreme heat events, simply because we're seeing the baseline level of our average, seasonal temperatures or annual temperatures increase because there's more heat that's trapped by greenhouse gases. And the consequence of that shift in the average temperature is that the number of extremes, the likelihood of extremes, including the likelihood of record-breaking heat, like we saw in the Pacific Northwest and we saw this year in Europe, are increasing simply because there is this warming. So this link between global warming and the increased incidence of extreme heat is pretty well established, and we are seeing across the world an increase in the number of extreme heat events. In addition to extreme heat, we also are seeing an increase. We're also seeing an intensification of precipitation events. And this is happening because, again, by a phenomena that's really pretty well understood in the climate community, that as the atmosphere warms, there is more evaporation, and the capacity of the warmer atmosphere to hold moisture increases. And so for about 1 degree Fahrenheit increase in temperature of the atmosphere, it can hold about 4% more water vapor, which means that when there are storms, when there are meteorological phenomena that produce rainfall, like tropical storms, hurricanes, monsoonal systems, when they do occur, they tend to be heavier. And so again, this is something that's been pretty widely observed across the world. We're seeing an intensification of the heaviest rain events because of this particular phenomena. The effect of this increase in heat and the increase in humidity is resulting in kind of what we consider a deadly combination. So when we have humid heat because of rising temperatures and rising humidity, we actually, so this is this is a growing hazard that is being studied in the climate community. So this is the combination of heat and humidity. So for those of you that are from Florida, you probably are familiar with humid heat, where the humidity basically increases the heat stress that we experience, particularly at high temperatures. So it makes warm temperatures feel hotter. And so prolonged exposure to wet bulb temperatures, which is a common measure of heat and humidity, can result in heat-related illnesses, at temperatures, at wet bulb temperatures close to 35 degrees Celsius, they can be fatal, unless you have some, access to external cooling. And so we've actually seen that this combination of heat and humidity is becoming an increasing hazard in many parts of the world. And people that are most exposed to this are people that are involved in agricultural activities, outdoor activities, or construction workers, or in any other like outdoor industry. And here, 35 degrees of wet bulb temperature is considered to be fatal. Basically, our bodies just cannot cool down because normally our response is to sweat, and when you're getting to heat and humidity conditions that amount to wet bulb temperatures of 35, it basically means that we cannot cool off by sweating. And so that basically that can be prolonged exposure to that, and by prolonged I mean even a few hours of exposure to those temperatures can be fatal. And these temperatures, maybe not 35 degrees, but close to that, have been observed in parts of the world. And the temperatures even below that can have impacts, like temperatures. So the heat index values close to 28 degrees can already have damaging impacts on human health. And in fact, during the heat wave in Chicago in 1995, these wet bulb temperatures were close to 27 or 28 degrees, and there were that was a really there were a lot of deaths associated with that particular heat wave, and that was because it was this combination of heat and humidity. And so some of the work in my group has looked at how these conditions are changing. In particular, we looked at the trends in the number of humid heat events and all the areas on this map. So this map shows the number of days in a year, the increase in the number of days in a decade with extremes in humid heat. And I've highlighted a couple of regions here. So South Asia, Southeast Asia, the Arabian Peninsula, parts of West Africa, parts of South America. These regions are experiencing significant trends in the number of humid heat extremes. And these are areas where already humid heat conditions are pretty high. So these extreme values are getting close to those thresholds that are dangerous for human health. In the US, the Gulf Coast, there are certain areas in the Gulf Coast and the Eastern US that are experiencing significant trends, although for most of the US, we don't see significant changes in this, but we're talking about trends that have occurred in the last 40 years. But moving forward, we are expected, climate projections show that that these regions in particular where you see significant increases, and significance so we're talking about statistical significance, and areas that don't have these dots on them are areas where these changes are significant. That means they're outside of what natural variability would result in. And so all these areas that where we are seeing significant trends already are areas where these humid heat extremes are likely to increase. And in addition to that, parts of the southeastern US are also expected to see temperatures, humid heat extremes, reach those critical thresholds, those temperatures that are considered dangerous for human health. With the trends that we have seen, with the trends that we have observed over the last 40 years, we have seen a pretty substantial increase in the number of people that are being exposed to these conditions. In particular, that's because these conditions are occurring in places where there are a lot of people. These are some of the most densely populated regions in the world. And so because of these rising temperature and humidity conditions occurring in places that are already densely populated, we are seeing an increase in exposure to these humid heat conditions, and that's shown by the blue line here. In fact, in some of the recent years, the exposure, the global exposure is almost 2 to 3 times higher than what it was in the 1980s. And so that's a pretty substantial increase, given that over this period, warming has really only increased by about 0.7 to 0.8 degrees. In addition to these hot and humid conditions, we are also seeing hot and dry conditions increase. We are seeing that climate change is increasing the risk of wildfires. It's doing that because as temperatures rise, there is more evaporation from the soils. So soils get drier, our vegetation gets drier. We're also seeing snowpack melting sooner. And so because of the drying landscape, as well as the earlier snowpack melt, those conditions increase the risk of wildfires, as well as droughts, we are seeing a pretty clear increase in the severe, like the large fires that we are seeing in the Western US. There's more area being burned in the Western US associated with wildfires. That has also been attributed to partly been attributed to climate change. But one of the consequences I wanted to talk about I know I don't have too much time here, but I just wanted to talk about one impact that my group has been studying. So this is a satellite image that shows smoke from the fires that were burning. This is an image from September 2020, September 15th, 2020, where there were fires burning across Washington, Oregon, and California. So all the areas in deep red are areas where there was dense smoke associated with fires. And the smoke, the smoke from here, we can see it on the satellite image. It didn't just stay here in the Western US, and it was transported across the country. And on the ground, it looked like this. So those of you who are from California, I know many of you are from there. You're probably familiar with this. Like recent wildfire seasons have had a number of days where there's just dense toxic smoke from wildfires that are present. And this is actually a real image. It's not from some climate catastrophe movie. And if those of you that are from Oregon, from the Northwest, you probably remember those orange skies that lasted for several, actually a couple of weeks. And it was really hard to even be outside. So the work that my group has been doing has been looking at how these increases in wildfires as well as extreme heat are affecting exposure of people in the Western US to harmful air pollutants. In particular, we've looked at particulate matter and surface ozone. And surface ozone is also another harmful air pollutant, which we've to some extent forgotten about because it used to be a much larger issue a few decades ago. We've seen pretty large improvements in air quality, but both these pollutants are harmful for human health. They have a number of impacts associated with them, from cardiovascular issues to respiratory issues, from headaches and irritation to premature mortality. And so across the US, across the Western US, in all the areas that are in red with a dot on them are areas where there has been a significant increase in the past 2 decades with days where people are exposed to extreme levels of PM 2.5 and extreme levels of ozone simultaneously. And we have found that this is mainly because we're seeing this increase in wildfire activity. Because historically, before we had these large fires, most of the particulate matter used to occur in the winter season, and these two harmful pollutants would not co-occur. And so now because of the fires, we're seeing this like increase in the co-occurrence of these pollutants. And we're seeing that these are affecting larger regions of the US simultaneously. So in the last 20 years, we've seen the fraction, the extent of the Western US that is simultaneously exposed to extremes in these two pollutants basically double. And in particular, in 2020, nearly 68% of the Western US was experiencing these extremes in these air pollutants. This increasing frequency and extent of this exposure to harmful air pollutants means that more people are being exposed for longer. And so we looked at this cumulative measure, which is basically the number of people times the number of days people are being exposed. And we are seeing an increase in that as well. And in recent active wildfire seasons, the number of these or the amount of population exposure that's measured by this person days measure that we used is like almost 3 times the average of what was experienced in the 2000s. And again, these have a number of health impacts associated with them. And again, the people that are being exposed to this so the impacts of these extreme events are being experienced differently, right? People that are in the outdoor industry, farm workers, construction workers, people in the service industry are more exposed to these conditions. And so I talked about 2 different types of extreme events that are changing, and these events are not occurring in isolation. We are seeing that, you know, with warming and the increase in the likelihood of many different types of extremes, we're seeing these events happen more and more. Climate-related disasters happen simultaneously. So I don't know if any of you noticed that in this image that I had just shown, where I showed all the fires burning in the Western US and the smoke being transported here, there were also, there was Hurricane Sally, I believe. I might have gotten the name wrong, but there was a hurricane that was affecting the Gulf Coast at the same time. And in 2020, there was a record fire season in the West and a record Atlantic hurricane season in the East. And I bring this up because the fact that we're experiencing multiple disasters simultaneously, that affects for one, it affects the ability of communities to respond. But when you have, you know, simultaneous disasters occurring, there are also, you know, national emergency response that we depend on. And in 2020, FEMA was like really stretched thin because they were responding to these multiple disasters, and that affects our ability to respond to these. And even in the Western US, you know, typically there's resource sharing between states when they're dealing with fires, but with simultaneous fire activity across multiple states, again, that affects the ability of communities to respond to these disasters. So in addition to, you know, thinking about isolated events, the climate communities has really been understanding how these simultaneous disasters are likely to change. And, you know, just simply by chance, because we're seeing an increase in so many different types of extreme events linked to climate change, we are expected to see more simultaneous disasters happen. Here, I discussed the implications of this for disaster management and disaster preparedness, but there are also implications for, you know, global, you know, when there are disasters happening globally, there are implications for how the impacts of these disasters can cascade through interconnected systems like the global food network or supply chains. As these disasters happen, we see that the impacts of these are not distributed equally. And I think this is something that we really should be thinking about. Different populations experience these climate impacts differently. So children, or elderly people and people with pre-existing conditions are more susceptible to the impacts of extreme events, for many types of extreme events. And then low-income communities and communities of color experience disproportionate risks, both because they are exposed to more, because where they live they are exposed to more climate hazards, and also because they have less disaster management or disaster preparedness resources. And so they're getting, they're experiencing a disproportionate level of hazards and disproportionate impacts that are associated with these events. And this is something that we need to think about as we plan for adaptation, as well as for our disaster preparedness. Because even if we do stop warming, well, even if we do stop reducing our emissions, we still have some time before that happens, and we still have some level of warming that that is projected to continue. Let's say if you're feeling optimistic, we're going to keep our warming to 1.5 degrees. That's still warmer than present, which means that there is going to be an increase in the risk of extreme events, even associated with that small level of warming. And adapting to those and preparing for those disasters is really important in thinking about reducing the impacts of climate change. So I'm almost done with my presentation. I know that people get really mad at me when I just present really depressing information and don't give people any suggestions on what they can do. So there are things that we all can do, from things like individual food choices, because those matter, to collectively like advocating for like transitions in our energy system towards less carbon intensive sources of energy like wind and solar, to also being part of adaptation and response. And so, for example, you can volunteer if you live in a city and there are heat waves or extreme cold events, you can volunteer at local shelters that are out there to protect the most vulnerable in our communities. And so that's one way you can engage directly with this. That's something that I like to do. And then there's many other things that you can do, as y'all probably already do a lot of this. Thinking about who you vote for, if they are thinking about climate adaptation and preparedness, learning about climate change and how it's going to affect us, and the many ways in which it's already affecting our food, water, energy, our health. Educating other people can really help. Volunteering in the way that one of the ways I just mentioned, but there's so many other ways to do that. And then also to advocate like y'all already do. So with that, I will stop. I know that was a lot of information, and I'm happy to take any questions. Hopefully I didn't go too long.
No problem. That was a really informative summary of climate change impacts on extreme weather. So thanks very much, Dr. Singh. So if you guys have questions, go to pollev.com/CCL123, which Tamara has pulled up on the screen here, and you can ask questions there or upvote the existing questions. Before we get to those, I'm going to abuse my power here and ask a question of my own. Because you were talking about the intense humid heat that's especially in areas like India. And I was wondering how are people in those areas able to adapt to that increasing humid heat? Like, for example, are they installing more air conditioning or anything like that? Because I think we also saw somebody in the chat actually mentioned that in the heat wave that just happened, there was a relatively low incidence of heat-related deaths, it seems like, during that event. So like, how are people coping with this intense heat and humidity?
Yeah. So there are a few different things that are happening, and that's when we see so there's more education, there are more resources into helping manage and cope with these disasters. So there are cooling centers that are open, like especially in cities like Delhi, there are places where people can now go. And so there is a reduction in just the exposure of people that are outside, that, like agricultural workers, they tend to shift the time during which they are out on the field. So there's some shift in when they are working, when they are outside working. So that's a combination of factors that have led to lower deaths associated with this, and I think a lot of it is just preparedness on the part of cities and communities.
Okay, cool. Thanks.
Which is the opposite of what we saw in the Northwest, because a lot of people don't have access didn't have access to air conditioning here in 2021. And we sort of underestimate the impact of heat.
Yeah, and in the Northwest, it was like people really aren't accustomed to getting extreme heat waves, whereas I guess places like India, it's more normal, and so they're more prepared for that kind of thing.
Mm-hmm.
Yeah. Okay, so next question here is, what do you think about geoengineering, such as spreading atmospheric particulates? This would only be done as we approach or go past a tipping point and hopefully not stop these CO2 reduction efforts.
Yeah, I think the second part of that question is the important one, that I think our priority should be reducing our emissions. I think that some of the research that's been done in geoengineering suggests that there are negative impacts that are going to, some of these geoengineering efforts can have. And so that has consequences, because, I think there isn't really like an international policy on geoengineering. And so if there are countries that experience negative impacts from these efforts, that can just kind of have cascading effects on interregional conflicts. And I don't think we want that. And I think there's still a lot more to be done before we even think about, a lot more to be done in terms of understanding the impacts of this before we think about implementing it. So I think advocating for reduction in CO2, which is what we understand pretty clearly. And in fact, recent research has shown that if we reduce emissions, if we reduce CO2, the impacts of that can be felt pretty quickly. So I think that is, while we can continue to do research in geoengineering, I think focusing on CO2 reduction efforts is I think more effective.
Yeah, I think there seems to be a general consensus that geoengineering is like a break glass in case of emergency type of thing, where like it's good to do the research and be prepared in case there's like a super emergency, but we hopefully won't have to go into that area.
Yeah.
Okay. Do we know how much climate change contributed to the terrible flooding happening in Pakistan?
Yes, so there was a study that actually just got published a couple of days ago. So there's a group called World Weather Attribution, and you can go to their website and look at the results of that study. So they do this thing called rapid attribution, because as we as I mentioned, we have a pretty good understanding of how temperature and precipitation extremes are impacted by climate change, and so there is a methodology to just go and do this sort of attribution when these events occur. And there was an international group of scientists that looked into this particular flooding event and found that to some extent, the warming that occurred did contribute to increasing the amount of precipitation that led to flooding. I don't remember the exact number, but if you go to their website, you should be able to find that. Part of the issue with South Asia, which I'll mention is something that affects our ability to attribute events that are happening there, is that we don't, our climate models, which are one of the main tools we use for attribution, have issues with simulating some of these processes there. And so that has created a challenge in attributing some of the events there. But overall, we do see an increase in extreme precipitation events in that part of the world. And so the type of events we saw this summer with multiple heavy rainfall events affecting the region that resulted in the flooding, that is consistent with the trend and consistent with what we expect to happen with climate change.
Cool, thanks. So are the monsoons in that area one of the things that climate models have a hard time with?
Yes.
Yeah, Seems like maybe complicated for sure.
Yeah.
Okay, tipping points. At what point do you expect tipping points to occur? So any particular tipping points that you're familiar with?
Yeah, I think the just Arctic sea ice melt and a change in the melting of ice sheets in the Antarctic. Those are tipping points that studies have found are likely to happen in our lifetimes, depending on the level of warming that does happen. And there was a really nice study just a couple months ago that has talked about the likelihood of these even under the moderate levels of warming that are projected. There's that, and then there's also the Amazon. The Amazon is expected to, like, there's likely to be a lot of drying there, and because of feedbacks within the climate system, that can result in what's called Amazon dieback. So there's like forest dieback, which can affect the forests and ecosystems in that region, just because there can be like a kind of this drying there, which then affects the amount of precipitation that falls, which further increases the drying in that region. So those are tipping points that are, I think, expected to happen relatively soon. The one I mentioned in the Arctic and the Antarctic, the effect of those are to reduce albedo, which further exacerbates warming. So albedo is basically how much incoming solar radiation is reflected. And so as we have less ice, that can increase the amount of warming because there's less ice being reflected, more being absorbed. And those kind of tipping points are projected to happen, or there's some evidence that like they're already happening.
Okay, thanks. So rural Americans, ranchers, and farmers are deeply skeptical of climate change doomsayers sometimes. Droughts, fires, and floods have always been the reality of making a living off the land. I'm eager to hear ways to present long-term climate models that they'll believe. Any help would be appreciated.
Yeah, I think unfortunately climate change has, well, I guess it is a political issue, and it's become divisive, and I think if it, presenting, you could present data, which as a scientist, that's what I love to do, but that's not always the most effective. I think I think you could explain to them like the basic sort of science of what's happening, and potentially explain to them like the things that we're seeing are consistent with what the science understands and what the models project. And I think rather than focusing on whether it's human caused or not, and I think that's the problem that happens is when we talk about human caused climate change versus we just talk about climate change. I think as long as you can like communicate to them that we know that these are the sort of risks that they're likely to experience to some extent, and present information to them about, like, rather than talking about attribution of climate change to human activities, which is I think what creates some of the issues, if we just talk about the knowledge and the kind of, and present information about like the types of risks they're likely to experience and that they need to prepare for, that I think can help. At least that's what I try to do, is to focus on just what the science tells us.
Yeah, and actually I was just seeing there was a survey published last year that showed about 80% of farmers now believe climate change is occurring, which is a really big shift from a few years ago. So
Yeah.
I think, when you're growing crops and seeing the direct impacts, then sooner or later it becomes pretty clear and you have to kind of accept it. So that's nice progress, at least among farmers. As someone who lives in Florida, our biggest concern about climate change focuses around sea level rise. What are some resilient tactics we can take so we can advocate pertinent steps to the community? Yeah,
so the direct impact of sea level rise is that there's likely to be more flooding there's more likely to be more flooding when even without storms, so what we call as sunny day flooding, and also increased flooding when storms occur. So higher storm surge would cause more flooding in coastal areas. And so thinking about how to, basically, well, there are multiple things that can be done. There are nature-based solutions, and then there are things like seawalls that can be built to reduce the risk of flooding. So thinking about like how potentially wetlands can be used, like expanding, increasing wetlands can help reduce the risk of flooding. So there are some solutions like infrastructure solutions like that can be implemented and that are being implemented in many places. And the concern, a lot of times the concern is that many people many times when these events occur, the communities that are experiencing that flooding are often community like low income and communities of color that are in areas that like low-lying areas that experience a lot of flooding. So thinking about how to invest more resources to reduce the risk of flooding and increase disaster preparedness resources will both help towards reducing the impacts as well as being resilient to increasing impacts of sea level rise.
Cool, thanks. The Kigali amendments. So the Senate, I think, just ratified the Kigali amendments to the Montreal Protocol, which is basically helping to phase out chlorofluorocarbons, which are very potent greenhouse gases. So do you have any thoughts on the importance of that?
So I think we can draw on the success of the Montreal Protocol, because that was, again, an international problem that was recognized and immediately acted upon by countries across the world to reduce ozone depleting substances. And so there are many similarities between the policies and like these international protocols that were in place to reduce ozone depleting substances. For those of you that don't know, the Montreal Protocol was really effective in an international, basically gathering an international effort to reduce aerosols and these chlorofluorocarbons that impacted the ozone layer, different from ozone that I was talking about earlier. This is the ozone that's in the upper atmosphere, in the stratosphere, actually. And so the ozone hole has actually responded. There's been more like stabilization of the ozone layer, the ozone hole, sorry. And this Montreal Protocol was really effective. So drawing on principles of that to getting an international climate agreement is, I think, the kind of best thing we can hope for. There are many similarities, as I mentioned, between like the Montreal Protocol and efforts to have international policies on climate change. So yeah, I think I think that's kind of, yeah, I'm not sure what else I can say about that. But it is something, it's a success story we can rely on for international cooperation.
Yeah, and it was nice to see like a bipartisan support for it in the Congress this year. Okay, I'm concerned the statement about the warmest in 2,000 years leads most folks, I think, to conclude that it must have been warmer not long before that. So maybe things will reverse and cool again. Is there more we can say about why we are, I can't read the last part. But why it only goes back 2,000 years.
Why we're just addressing the last 2,000 years. Yeah, so the reason we say the last 2,000 years is because we have, well, for two reasons. One, that's a time period that like the humans as we know today have lived. That's part of the reason. And the second kind of the second reason, the main reason we actually look at that 2,000 year period is because we have the most reliable record for that. The most, we have tree ring data, we have corals, we have other sources of paleoclimate information that can give us a pretty reliable record going back to 2,000 years. We do have longer term data than that from ice cores that show that actually, before then, there were these like glacial interglacial cycles. So over the last 800,000 years, we presently, I mean, from these ice cores, we can get the concentration of CO2, and we can sort of estimate the temperature, the global average temperatures. And so, basically from that ice core record for the last 800,000 years, we have seen that present levels of CO2 in the atmosphere are higher than they have been. During glacial interglacial cycles, they used to be between 180 to 280 parts per million. We are close to 420 parts per million. Based on our temperature record, going back to that, which is beyond 2,000 years, is less certain. We can kind of infer that temperatures were not as warm as they are today, and there have been multiple studies that have like tried to estimate temperatures using different sources of paleoclimate information, and have found that of course there were times in Earth's history when the Earth was warmer. There, like in the Paleocene, Eocene thermal maximum, I think that close to like 65 million years ago, when the Earth was very different than it is today, it was 10 to 12 degrees hotter. But we haven't seen the kind of rate of increase of global temperatures based on the best available data to be anywhere close to what we are at right now.
Yeah, it does get tricky because like the further back in time you go, the larger the uncertainty gets. And so it's really like, it's hard to say like there was no period because like when it was this hot, because there's this big uncertainty bar. But there is also like this really strong correlation between the atmospheric CO2 and the temperature. And as you said, like atmospheric CO2 is so much higher now than it was like any time in the recent past. So you can kind of infer that it's probably hotter right now too.
Yeah.
Can changes in the way we produce and use textiles like cotton help ameliorate the impacts of climate change?
So I don't know specifically about textiles, but I think, in general, like our consumption, the way we produce a lot of different products that we consume are very carbon intensive, the way they're produced. And so I think there are there certainly can be changes, but I don't think I know specifics, can really comment on specifics about the textile industry.
Yeah, I know there's been some recent articles about like the large footprint of the fashion industry, but I haven't read those either.
Yes.
So
Yeah.
Are there certain companies or industries that especially harm our climate?
So I mean, most of the fossil fuel industries are they've for decades have been misleading the public on the impacts of climate change. And if you haven't watched this already, Merchants of Doubt is a really good documentary to watch, and a book to read by Dr. Naomi Oreskes, who talks about how they've been kind of advocating for continued investment in fossil fuels, and have continued to mislead the public about the impacts of this. I would say that those companies are like many of the leading fossil fuel companies are kind of primarily responsible for the climate, production of CO2, but there's also like, it's hard to say because we have so many different sources of climate change, of greenhouse gases. There's everything from our energy production to construction to transportation to agriculture that contribute greenhouse gas emissions. So we certainly can. There are like fossil fuel companies can are there's certainly attribution of greenhouse gases to those companies, but many of the processes that give us what we consume every day produce greenhouse gases.
Thanks. We've probably got time for one or two more.
Yeah, Dana, I'm going to let you take this last question right here, and then I'm going to transition us to our last closing slides. This is a good segue.
Okay. So people would like to see your presentation or at least the visuals in it. Is there a way they can access them?
Yeah, I can just send it to you and you can send it to everybody. Yeah, this is all public information.
Cool.
Dana, is there a way to post this in the Nerd Corner perhaps somehow? Or we can post it in the event of this in the text of the event, this event, if not on the Nerd Corner somewhere.
Yeah, I mean, on the Nerd Corner, which Nerd Corner is a nice spot that we can plug for our CCL volunteers on community. If you go to cclusa.org/nerd-corner, there it is on the screen. We have a nice corner of the CCL community where we, chat with the research team and volunteers talking about nerdy stuff, like extreme weather events, for example. And we do have like a files section in there, so we could potentially put the presentation or graphics up in the files on the Nerd Corner there and share them that way. So that might be a good way to do it.
If you are interested in logging your training, which is a great way to catalog what you have done in CCL, there are a couple of ways. You can click this log your training at the end of each training. We have a green button, and the climate science basics one, the interactive one, you can do that by going to this log your training as well. And you can also do it through the action tracker through the chapter and volunteer development tab by just typing the first 4 letters of the training name and it will come right up. Thank you so much for joining us this evening. You can join CCL if you are new to CCL, cclusa.org/join. Deepti's website is on the screen as you can see it there as well. And you can also find Deepti at Climate Chirper. I don't know your pronouns, Deepti, so I keep calling you them. So my apologies.
That's fine. Thank you.
You're welcome. And you can also, there's that climate science basics on the screen as well. So thank you, Dana, for co-hosting, Deepti for all of your amazing work in the world, and to all of you who are here this evening for your passion and your concern. Have a wonderful rest of your evening. Good night, everybody.
Thanks, Deepti.
Thank you for listening to this episode of Citizens Climate Lobby's training program. You can tune into more episodes anywhere podcasts are available. Inspired by what you heard today? Join Citizens Climate Lobby to advocate for bipartisan climate solutions. Go to community.citizensclimate.org to find more trainings, resources, your local chapter, national action teams, discussion forums, and more. Be sure to like our Facebook page and follow us on Twitter and Instagram @CitizensClimate. We also invite all of our listeners to subscribe to our YouTube channel for more inspiration.
Like what you hear? Recommend us to your friends and make sure to give us a 5-star rating. It helps us show up on other listeners' feeds. Feel free to pass on any suggestions for future episodes in the comments as well.
And together, we are creating the political will for a livable world.